All right, so decimal again, we have ones, we have tens, we have hundreds. So, you know, I have this big ladder that's 100 feet tall. I have a bunch of 10-foot ladders that are smaller and a bunch of 1-foot ladders. So if I need to go to a building that is 328 feet tall, right, I know exactly what I need to do. I need to grab 3 of these, 2 of these, and 8 of these. So I'll put my 3 100-foot ladders, I'll put my 2 10-foot ladders, and I'll put my 8 1-foot ladders, and I'll be able to get to the top of that building. How do I do that in binary, right? I don't have 100-foot, 10-foot, 1-foot ladders, right? What I have one, 2, 3, 4, 6. Right? I have a 1-foot ladder, a 2-foot ladder, 4-foot ladder, 8-foot ladder, 16, 32, 64, 128. So let's say all right, so let's say I want to get to 67 feet tall. All right. So what I do is I start on the left-hand side and I say, do I need a 128-foot ladder? Right? No.
No.
Because 128 feet is way too high. I would fall off the end and die. All right. What about 64? Would that help me get to the top?
Yeah.
Yes. All right. So I'm going to grab a 64-foot ladder. And I'm going to put it all the way up here. So this is 64 feet. So now I know if I put a 64-foot ladder here, I only have 3 feet left to go, right? I only have 3 feet here. So a 32-foot ladder, again, is going to be way too much. I do not want that. 16-foot ladder, way too much. Do not want that. 8-foot ladder, still too much. Don't want that. 4-foot ladder, getting close, excuse me. Still going to put me over the edge. I'm going to fall off. All right, finally, I get a 2-foot ladder. Yes, 2-foot ladder will get me closer to the top without putting me over. So I have a 2-foot ladder here. And that means I only have 1 foot left to go. And not surprisingly, I do have a 1-foot ladder. So this number right here, 010000011 equals 67 in binary. All right, so I'm going to do another example. Let's do so 156. Okay. So I know right off the bat here that I'm going to need this big ladder, my biggest ladder, 128. So I'm going to put this 128 foot ladder up here. And how much do I have left? Well, 156 minus 128, I got 28 feet left. So again, 64 is going to be too big. 32 is going to be too big. 16 is less than 28. All right, so let's use a 16-foot ladder and put it up here, 16 feet. So now, oh, so that was 28 minus 16, so I have 12 left to go. So 8 will fit, 8 will fit, and now I have 4 left to go. So I have a 4. And then I'm already at the top. So I don't need my 2 foot or my 1 foot ladder. And this number right here, 100111100, equals 156 in binary. So all I'm doing every time, the algorithm that I'm using is picking the biggest number that fits in here. Then I pick the biggest number that fits in here, then the biggest number that fits in here, and the biggest number. If I keep picking the biggest number that still fits, then I'm gonna end up at the end here with the sum of all of these being my number. So 128 plus 16 plus 8 plus 4 equals 156. And so that's what makes going the other way even easier, right? So if somebody tells me a number, I don't know, say 010101110, I don't know what that is, but I can just match it up with these numbers up here. So somebody tells me this number right here and asks me, hey, I saw this number in binary, what is it in decimal? All I have to do is add up the columns, right? So this has a 0, don't need it. This has a 1, 64. 32, 0, don't need it. 16, 8, nope, 4, and a 2, right? So these are all the numbers that had a 1 next to them. I add those up, and I get 86. So this number, which I didn't know in binary, equals 86 in decimal. And I did that just by adding up whichever ones have 1s next to them. So hopefully that makes sense. Does anybody have any questions right off the bat?
Could you go up to like 256 instead of just like, is like 128 the highest it goes, or does it like just keep going?
It goes until the computer runs out of memory addresses.
So that is a really good question, actually. So what is the highest number I can get to, whoops, with just 8, right? So that's a really good question, actually.
Should be 255, right?
So somebody gives me the number 1111111, right? I can't go higher than that. That's like in decimal, right? If I said 999999999, if I only have 8 spaces, that's the highest I can go in decimal, is 999999999, right? In binary, I only have 0 and 1. So the highest I can go to is 1111111. Well, let's add it up. 128 plus 64, 192. 192 plus 32 is what? 224. 224 plus 16 is 240. 240 plus 8 is 248. Plus 4 is 252. Plus 2 is 254. Plus 1 is 255. So if I set all of these numbers, if I grab all the ladders off my truck and pile them up one after the other, the highest building I can get to is a 255-foot tall building. And going back to one of the earliest questions I asked, right? Well, what if I have a 300-foot tall building, right? Obviously, computers can store numbers bigger than 255. If I only have 9 symbols and I need to count higher than 9, what did I need to do? Somebody can answer.
Add an extra bit.
Add an extra column, right? So if I need to go up to a 300-foot building, all I got to do is add another column over here. And in decimal, we multiply by tens. We have 1s, 10s, 100s, 1000s, 10,000s, blah, blah, blah. In binary, we multiply by 2s. 1, 2, 4, 8, 16, 32, 64, 128. So this will be 256. So if I wanted to go to a 300-foot tall building, right, I would need that 256-foot tall ladder. Let's do it this way. 256. And I would be left with 44. So I don't need the 128. I don't need the 64. I do need the 32. 32 leaves me with 12. So I don't need this 16. I just need the 8 and the 4 to make 12. So that is 300 in binary. Right? And the highest I can go with this is 511. If I need to go higher than that, I have to add an extra bit, 1023. If I want to add an extra bit, add an extra bit. So I can keep going, kind of like Antonia said, I can keep going until my computer runs out of memory. But in reality, programming languages just say like, all right, integers can go up to like 100 billion, and that's all we're going to allow you to do. If you need to go higher than that, then you need like a special variable or something like that. So in reality, most computer languages, right, originally they just started with 8 bits, right? You've heard of 8-bit graphics, right? That's why. And then, so now most computers use 32 bits to store numbers. So that's 32 columns.